So we are just adding to the part we were discussing earlier, is hydrolysis, solvation, and hydrolysis, solvation, and dissolution. So where we have seen that how a metal salt get dissolution process first and then hydrolysis, unlike the organic salt one. So we will consider here in this lecture acidity of metal salts. Acidity of metal salts. All right. So exactly, not wasting time here and there, exactly focusing where we just left in the last lecture, we ended up that when we add like things like this, when we add sodium chloride salt and we dissolve it in our water, what happens? Something of this kind get formed. Something of this kind get formed. This kind of get formed. This is what we call metal aqua complex. Metal aqua complex. All right, just let me have a new chalk. Metal aqua complex. Up to here, I said this process is what? Up to here, this process is called dissolution because it is a physically governed process, not a chemical process. Chemical process typically means bond breaking and bond formation. And if what happens, if this if this metal aqua complex get further reacted with water and results into something like this, N-1 OH, no charge is balanced, and this is called what? S3O hydronium ion. Then what happens? Typically this metal aqua complex, a complex ion, is giving what? H plus. So any chemical moiety, just apply the definition of acid here. Any chemical moiety when dissolved into a water or any suitable solvent gives what? H plus ion in excess. What it is called as? Acid. It is like behaving like what? Acid. If we just try to compare it, just see. I am writing down here H2O, N, M plus this one, and this is reacting with what? Water. I am just writing a typical acid plus H2O. What will happen? You tell me. This will happen like this, H2O, N-1 OH, this will happen, plus H plus, this will happen. And if I do this, what will happen? The same thing, Cl minus plus H plus, this will happen or not? And this H plus will react with what? H2O and will give what? This will be giving an H plus ion to the water molecule and imbalancing the H plus and OH ion concentration in a solution, and the resulting solution will be what? Acidic. Acidic or not? You know, here this is the same thing happening. This H plus will get associated with the H2O molecule and this will be ultimate product, hydronium ion. Then HCl and these two are working same way or not? So this metal aqua complex is behaving like what? Acid, isn't it? And to your surprise, although this is the least acid, this is the least acidic metal aqua complex ion, so its acidity is not very significant or not very visible. But if this metal ion sodium is being replaced with the metal ions, those are having higher charge to size ratio, the acidity of those metal ion complex could not be avoided. Means if I write these three complexes, if I write like FeH2 6, this one, if I write this one, if I write this one, the acidity of these metal ion complexes, acidity of these metal ion complexes is comparable to, it is comparable to acetic acid. It is as acidic that this acetic acid. Now you know this is the proper acid. Acetic acid is a mild acid, isn't it? The acidity of this acetic acid and the acidity of this what? Complex salts is almost equal. So there, although it's insignificantly acidic, it's not measurable, but the acidity of these three ions cannot be ignored. That means simply if you dissolve this FeCl3, if you dissolve AlCl3, if you dissolve BeCl2 in water, okay, the solution resulting from these two would be what? Acidic. These are called acidic salts. Alright. And now interesting thing is this, why this is not that much acidic and why these three ions are acidic. This is the question, important question, isn't it? So this could be understood the way, let me tell you. How this acidity appears basically. Let me give you some simple picture of acid. This is the beaker. Let me draw a bigger one because this would not lead acidity in your body itself when the explaining is difficult. Okay, so this is the beaker. This is a field of what? Water. This is what? Water. Now tell me, at room temperature, means 25 degrees centigrade or so, the pK W of this water is what? 14. Alright, why this is so? At room temperature, this will be ionized or not? Water will get ionized or not? Will not ionize. It will be partially ionized. Alright, you can say this may exist in what? This will be ionized. And this is not written like this in a solvent still because this is simply a proton. So this is rather written like what? S3. The moment it will get free in the atmosphere, it will combine with the next water molecule, it will be hydronium ion. So it is not a free because it is a subatomic particle, it is not just any element. Proton without electron is what? Hydrogen without electron is what? Proton. and it is not even atom, it is not even element, it is subatomic particle, it is a nuclear entity. So it is not free in any solvent. The moment it will get free, it will associate with the next molecule, will form hydronium ion. Alright, at any given time at room temperature, the H plus ion and what? H plus ion and OH negative ion are exactly equal. Alright, then this is what we call neutral. Okay, neutral. And if H plus get higher than little much OH minus, it's called what? Acidic. And if the reverse is true, what we call it? Basic. This is the requirement of acidity or basicity. And if you dissolve FeCl3 into this, what will happen? Fe will get associated with a number of molecules, alright, H2O will form this kind of things. And if this molecule itself liberates one H plus ion for free, what will happen? The resultant H plus ion or hydronium ion in this neutral solution will be higher than what? Will be higher than hydroxyl ion. So resultant solution will become slightly acidic. Anything that you dissolve in this neutral solution called water, neutral solvent called water, and it releases any moiety inside it in a manner that it imbalance the ratio of H plus ion OH minus ion, the resultant solution will be either acidic or basic, depending upon whether it is helping to get excess H plus ion or hydroxyl ion. Alright. So this is the way, the things. Why this happens? The question was why this happens in the case of what we call in these three ions and not in this ion. This is the question. So just look at. I said that in this case there is a bond like what? OH and OH. Is it a bond or not? This is the bond. There are other bonds, 6 bonds. This is the complex or not? This is the complex, this is the complex, this is the OH2, OH2, this is the OH2. I am just considering one bond. And let's say this is the iron one. And here the bond involved is this one. This is the bond. Alright. Now, react with these three ions with the water molecule. OH2, 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 water. Okay, this is simply water. This is simply water. How this reaction will be easily facilitated? This is the singly charged. This is what? 3 plus charge. Is it or not? Alright. So which one? This is the bonded pair of electron between iron and oxygen. Iron and oxygen. Now tell me, electronegativity of sodium ion is higher or sodium plus ion? Which one has higher electronegativity in these two? Sodium plus or sodium ion? The electronegativity of this ion is high because it has acquired a positive charge. The neutron to proton ratio has got disturbed. There are more protons than electrons. Proton electron ratios got disturbed. So there are more protons in the nucleus than the electron itself. So it can attract extra electrons. So electronegativity of any charged ion compared to its neutral atom is always higher. Okay. Now consider Mg2 plus. Which one having a higher electronegativity? Magnesium 2 plus, because the charge in 2. Don't consider other factors. Simply the charge is higher, electronegativity will be higher. Alright. So here this is the plus 3 charge, this is plus 1 charge. So electronegativity of this iron atom is higher or not? Higher. So this will be attracting this bonded pair of electron very strongly. Isn't it? and this will be attracting this bonded to electron little weaker sense, in a little weaker, with a weaker force. So if this attracts electron with a small force and this attracts electron with a small force, the polarization of FeO bond will happen in which case? Here the polarization will be higher. Means oxygen is getting what? Positive charge. If it is withdrawing electron from this bond pair toward itself, oxygen will acquire what? Positive charge. And just to, of course, oxygen cannot reverse the pull of the electron from this side, then oxygen will withdraw electron from where? From hydrogen oxygen bond. Then oxygen in a response to this action will withdraw electron from here. So what would happen? The net positive charge on proton atom will increase. So here will be what? More higher partial charge, here will be little less partial charge. And if the charge on this hydrogen atom will be higher, so it will much easy to free. For this proton, it is quite easier to get free from this molecule. Alright. So simply this will transfer its electron and this reaction will favored by very normal sense. FeOH and S3, this will get formed. Okay. So in this case, or if it is aluminum 3 plus or it is a barium 2 plus, if these metals are involved, so this process is quite easier. That's why what happens? These 3 ions that I noted here are exactly acidic to the extent of what we call acetic acid. Alright, that's why these metal ions. And what is happening? If you just exactly go, why this B negative B2 plus is much more even, it is acidic than even iron. It is 2 plus charge and iron is plus 3 charge, but it is the aqua complexes of beryllium are more acidic than the iron itself. Even aqua complexes of beryllium are classed as amphoteric complex. They behaving like acid and base bond. How this could be explained? Because what explanation I have served to you, it is a half explanation, it is not complete explanation. What is important? It is not simply the charge of metal atom which is making more acidic or more basic. It is in fact a term called ionic potential. There is something called what? Ionic potential. Ionic potential. Ionic potential is represented by sigma or phi. This is nothing but Q by A. Now it is clear to you. Although in the case of beryllium, the charge is quite less, but size is much more small. Size is much more small. So this phi is high than to case of iron. So the ultimate ionic potential, because you know in physics what you study, what is ultimately responsible for attraction? It is not electron, it is not charge. What it is exactly? That's why I often call, just please pay attention to the word and phrases that has been written in the books. Now otherwise you will suffer like this. It is not the charge exactly which are responsible, it is what we call charge density. And now in a convenient language of inorganic chemistry, this phi is what? Charge density. It is not density, some quantity with a ratio of area is what? Density. So the charge density in the case of beryllium is higher, that's why it is attracting more strongly. And these ions behave very interestingly. You often will find in organic chemistry precipitate of this kind, aluminum OH6. You will find precipitate of this kind. These things get precipitated in solution. Why this precipitates happen? When they release all the proton and become completely a new moiety, they got precipitated because they gone insoluble in a solvent. Okay. So this is how inorganic chemistry works. So now basically in general in competitive exam there are questions being asked. that what is the true order of acidity or basicity of these metal aqua complexes. And when they are in order, you can simply tell. What if I say which one is more acidic? Let me write an example. Competitive exams ask the way I am going to write here. Competitive exam ask like this. They will give you sodium, this complex, this complex, this complex, and they are asking the order of acidity. So you can simply say they are basically elements of the same group, isn't it? So down the group, when you move, what happens? Basicity increases. Increases or not? Means what? Acidity decreases. Alright. So which one will be most acidic? This one. Okay. And if you move in the same group, if I compare it with what? MgH2O, 2 plus, and then in a P block, in the same row. What is the order of acidity? Order of acidity will be like this one. You can relate it by two ways. When in a period you move from left to right, what happens? Acidity increases. So you are moving in a period, so acidity is increasing. Or you can simply relate with what? Charge increasing. This is the case of, this is the reason why acidity increases. Alright. Okay. Now, it is an ordinary question. In a higher and tougher exams, what will they will? They will mix everything. S and P block elements, they will mix. They will put aluminium, they will put D block elements. Like they will make a good concoction of FeH2O. They will ask like this. They will write this. And they will write like this, barium and beryllium. You will get confused. Both are +2 charge. Okay. Then you have to apply a rationale. If you don't know what we call this ionic potential and how we try to find it out, you cannot solve this question. Because you will find these two charges are same. And this one is the higher. And if you will say that this is the highest. This is again nonsense. And if you will do this, you will not be able to separate between these two, that which one going to be more acidic, because these two are having same charges. Alright. So now you have to know what we call ionic potential, charge density. This is how physics and everything works in a way, in a tandem way, and help you understand the things. Alright. So this is the part of what we call acidity of metal aqua complex. Alright. Okay, thank you.